Hey guys, here's what we're going to do. We're going to use this fantastic, oh man, focus, won't focus, it's blurry. Anyway, Dixon Ticonderoga number 2, a straight edge, and what we're going to do is we're going to tackle some statistics problems, Cambridge IGCSE style. So let's do it, right? Let's get into it. Here we go. All right, so what we've got is a graph right here. Make sure you read the instructions, even if you turn out to be right in your assumption. The instructions are telling you what to do, so don't assume it, because that's where a lot of mistakes come in. So first of all, use the cumulative frequency graph below to answer the following questions. The graph shows a length of hardcover books in a home library. So it looks like we go from 20 to, looks like around 41, maybe just a little more than 40, 32 total books. First question says, why does the graph start at 20, 0? Why does it start right here? Well, first of all, the reason it starts right there is because there's nothing smaller than that. Well, here's what we know. From 20 to 25 centimeters long, there were 3 total books. They could have all been 20, they could all been 22, they could all been 25. We don't know. So that's what we know. So let's read our answers. There are 0 books that were 20 centimeters. That could be true, but we don't know that for sure. Could be 0. We don't know. There were 0 books shorter than 20. That's it. There's nothing shorter than 20. All right. So, So we started there. Now, let's see. There were 0 books that were longer than 20. That's absolutely false. Not enough information. There's not enough information to know if there were 0 or more, but than 20. Yeah, so we don't know that for sure. All we know is that there were 3 of them between 20 and 25. Between here and here, there were 3 total books. All right. How many books were measured? 32. 32 books were measured. Next up, Buttercup. Number 3 says, how many books? Oh, there we go. Sorry, I'm sure you can see it here. Number 3 says, how many books were 32 centimeters or less in length? All right, so let's use our graph right here. How many books were 32 centimeters or less in length? Oh, well, that would be, let's see, 32 centimeters. That's right here. So draw our line up and over, it looks like 22. Now, if you're taking a paper 4 or a paper 2 Cambridge test, draw your line like that. Muy importante. You don't need to draw the arrows, but that's which way we're using those, and that might be good for future reference. So, 22, 22, however you want to say it. Okay, what is the longest book? What is the longest a book could have been from the status set? Well, if we look at this highest value right here, that's between 40 and, so that's more than 40. I don't know exactly what it is, but it's more than 40, because 40 is right here on this line, and it's past that. All right, so I'm going to have to say 41, between 38, 42, and 44. I mean, there's definitely more than 38. 38's right. 38's over here. We definitely, I mean, there might not be any that long. We know that there are, let's see, 4 books between 36 and 41-ish. We know that there are that many, but we don't know where they are. So the longest possible would be at the end point. And so that looks like 41 is the closest number to that value. Okay. How many books were between 28 and 36? 28 and 36. All right, 28 and 36. Let's be careful right here. Between 28 and 36 centimeters in length. So 28 right here. That's right there. There were 8 books. Okay, and 36. Make sure you guys can see what I'm doing right here. Up and over. Those are nice because I got the X's on there for us. So that looks like 20 books were between 20. 20. Okay, what's the median? So the way you find the median, remember the median is if you take, all right, so look, with median, if you take all the frequencies and you arrange them by size, smallest to largest, the physical middle is the median. So we need to figure out what the middle frequency is, and we have to find its value, right? So then if we have 32 frequencies, that means whatever the value of the 16th is going to be the median. So pull my glasses off because I'm old, I can't see. This is not the clearest graph ever, but I'm going to say the median looks like it's 30. There we go. Interquartile range, so that's the distance between first quarter of the frequency, the value of that, and the third quarter. So we have 32, right? So the first quarter is going to be 8, and the third quarter is going to be 24. right? So between 8 and 24. So we already know that at 8, the 8th frequency is 28. So now let's find 24. 24 is right here. There's 24. Draw your line and over and down. Oh, man. Looks like it's right in the middle. That looks like 33 to me. So from 33 to 28 is the interquartile range. So that's a range of 5 centimeters. Oh, wrong page. 5 centimeters. So about 5. That's our answer right there. Okay. Now, next question says the points on a graph marked with an X are the class boundaries. Okay, what is the modal class? So the modal class is the class with the highest frequency density. The highest frequency density. Frequency density is the frequency divided by the class width. And this is really meaningful information when the class widths are uneven. And so here, if we look at our graph, our class widths are uneven. See, look, we've got from 20 to 25, right? We have 20 to 25. And then we have 25 to 29. See, this is a class width of 5, and then a class width of 4. From 29 to 32 is a class width of 3. And then from 32 to 36, class width of 4. Now, I don't know the actual inequality rules that would populate this information, or this graph, but we just know it's in between, right? So then from 36 to 41 is a class width of 5. Okay, so now the class width with the highest frequency density is the modal class. So the frequencies from each of these we have to figure out. Now, usually, like, it's obvious, it's to me like the biggest growth between two consecutive of these x's is in between here. And so let's take a look at there. So 10 to 22, that's a class width of, or that's a frequency of 12 from here to here. That's from 10 to 22, that's 12. And that was from 29 to 34. So our frequency was 12. Let's see, hold on. Let me make sure that something tells me that I'm doing something silly here. 29. Oh, that's what I'm doing wrong. I got the wrong one. So our frequency here was 12. That gives us a frequency density of 4. So I'm making this little kind of chart over here as scratch work, right? So if I find the frequency of each and I find the class width of each, then I can figure out the frequency density. So that's going to be the highest one. And I know that's true because, like, if I look at the rest, let's go ahead and do this. I've got a class width of 3, so that's 0.6, right? 3 divided by 5. Here, I've got, so from 3 to 10, that's 7, right? So that's 7 over 4. That's 1.75. From 32 to 36, 32 to 36. So 22 to 28. So that's 6. So that's 1.5, and then the last one, 5, 28 to 32, that's 4/5, that's 0.8, if I did that right. Let me see. 28 to 32, 28 to 32, yeah, 4, so 0.8. So those would be our frequency densities. That one is obviously the greatest. So that was from 29 to 32. Okay, number 9 says, if the data presented in the cumulative frequency graph was presented in a histogram, what would the y-axis be labeled? Well, because the class widths are uneven, frequency density. Okay, now the data is presented in a cumulative frequency graph displayed. Oh, this data is presented in a histogram. So the data that's in the cumulative frequency graph is then translated and presented in a histogram. The class width with the highest bar is 29 to 32. That actually gives you the answer to number 8, right? And then on the graph, the height of this is 4 centimeters. How tall is the bar from 20 to 25? Well, check this out. If this is if the frequency density is 4 and the height of the graph is 4 centimeters, then it looks like for every value, every unit of frequency density, we get 1 centimeter, so 0.6. 0.6 centimeters would be the height, because it tells us that the height of this column right here on the histogram, which we don't see, is 4 centimeters, and it turns out the frequency density is 4. So it looks like 1 centimeter per every unit of frequency density. So 0.6 centimeters would be our answer. Man, that's kind of cool right there, man. I hope this was all right for you guys. Should we do more, or should we just leave it here? I think we're gonna make it 2 videos. We're gonna leave this first one right here like this, and we'll do the second one in a video coming up soon. Anyway, I hope it's been helpful. If you guys have questions or you want some clarification, just leave me a comment or something like that, and I'd be glad to hear from you. Hope you're having a good day.